Hi guys, this is 10L question 1. It says related rates of change. First question says if V is the volume of a cylinder with radius r and height h, write down the rate of change of the volume when in these two situations. We have when r is kept constant and the height is increasing by this rate, and then vice versa on the next one. Well, this is obviously talking about the volume of a cylinder. So volume of a cylinder is pi r squared h. Now, if r is kept constant, then this whole thing here, pi times r squared, is just a constant in front of something. So say, for example, if you had 4x, then 4 is your constant. So when you differentiate this, you just get 4. So if we differentiate this with respect to h, which is the thing which is varying there, then again, just like with this case, you'll just get this constant in front left when you differentiate it. So in this case, your dv dh is equal to pi r squared, because r is constant and h is the variable. Okay, and anyway, this one says write down the rate of change of the volume. So actually what we're asked for in this question is dv dt. Now we're going to use this related rates of change here. We're going to just split this one up, dv and dt, like this. We know that we can get out dv dh there, and we know as well that we've got dh dt is given. We don't know what this is, but it's some sort of function of t. So this is dh dt there, and we've got dv dh there. You can imagine, for example, that those two cancel when we're timesing together two fractions. Okay, so now we can substitute this thing in here, and we can substitute this thing, whatever it is, in here, and we get our final answer. So pi r squared dh dt is the final answer. Now dh dt could be, it's talking about how quickly the height is changing with respect to time. So it could be, for example, how the height is changing when you're filling up a cylinder. So maybe the height is changing at 1 centimeter per second. So that would mean to say that for every second, the depth of this cylinder is increasing by 1 meter per second. That would be the case where this is equal to 1. But it's quite possible as well that this is some sort of function of t, where your rate of change is dependent on the time. For example, you might slow down the rate of flow of the tap that's filling up this cylinder as it's getting nearer the top. So that might be some sort of function of t. But frankly, we don't know what this is. We're just asked to put the HDT in the end there. Okay, similarly for this one, let's just clear everything there. Similarly for part B here, we've still got the same formula, pi r squared h. But where h is a constant, so where this is a constant, that means to say, really, we've got pi h r squared, and this thing here is constant. So now we can do dv dr, and so that's going to be 2 times by the constant r. So that's just like saying r squared becomes 2r in differentiation. I've just split the 2 and the r up, so I've put the variable at the end, which would be normal. And now again, of course, we can do dv dt is equal to dv dt. Let's split it up. I can see r is involved here, so I'm going to put dr there and dr there. Dr dt is just this thing here. We don't know what it is, but it's just this. It's some function of t, or possibly it's a constant. And now we can substitute this thing in for dv dr as well, and that sorts out question 1b. Okay, I'm going to do question 2 here as well. So let's just do this. Okay, so for question 2, it talks about the volume of a cube. Well, cube, and it has a side length. Let's call the side length x. doesn't give us a variable there, but that would seem sensible. And we know, of course, that the volume of cubed is equal to x cubed, and the surface area is 6 times each of the area of the faces, x times x. So it also tells us here in the information that the increasing at the rate, the volume of the cube is increasing at the rate. And whenever they say rate, that's with respect to time. So dv dt in this case is fixed at 2 meters cubed per second. The rate of increase of its surface area when the cube has a volume of 20, or find the rate of increase of the surface area. But what are we looking for? We're looking for the s dt because it's a rate. And in this case, we can see, and it's talking about when the volume is 27. So V is going to be important here. Now let's just split up ds and t. Okay, and well, we can see we've got dv dt over here. So that's going to go in there. So that means that we're going to need a dv here as well. Now, in order to work out ds dv, we need a formula for s in terms of v. So we need to combine these two formulas here. Okay, to combine them, we can say x equals v cubed, cube rooted. So cube root both sides there. And then we can substitute that x into the s formula. So s is going to equal to 6 times v to the third, and then squared. Okay, and so that's going to give us 6v to the 2/3, that's s. And now we can do ds dv. So if we times by the 2/3, we're going to get 4. And then we're going to reduce our power by 1, and that's going to become to the minus a third. Or if you like, you could write that as 4 over the cube root of v. At that stage, we're pretty much done with this question, really, because we can then substitute ds dv into here, dv dt into here, and we can answer the question by substituting in as well, v is equal to 27. Okay, I'm going to do the next couple of questions in the next video, just to split it up a bit for you.